Okay, so we're trying to find where this function doesn't exist and where it's equal to 0. So notice that um, this guy is never equal to 0, the denominator, and so because it's always this guy, x to the fourth plus 27, can never equal to 0. So then if I'm trying to figure out where this whole guy is equal to 0, the very first thing I would do would be to multiply both sides by x to the fourth plus 27 squared, and that would get rid of this guy. Now the next thing I would do is simplify the top a little bit. Let me distribute these guys. So then what I would get is 12x to the sixth plus 27 times 12 is 324 x squared minus 16x to the sixth. And this is equal to 0. So I'll combine these two. That'll give me negative 4x to the sixth plus 324x squared equal to 0. Okay, and then to solve this guy, well, I'll factor. Let's take out a negative 4x squared, and that's going to leave me with x to the fourth minus 81 equals to 0. And so then from this guy, I'm going to get that x equals to 0 as a solution. And then this one, I'm going to need to solve x to the fourth equals to 81. So then what I get from this guy, well, I would have to get the fourth root, both sides. And so x is going to equal to positive or negative 3. So those are my 3 solutions. Okay, so to solve this guy, you know what'll help us is if instead of having it as tangent and secant, if I turn it all into sines and cosines, this would make it a little bit easier to solve. So I'm going to do sine of x over, so tangent is sine of x over cosine x plus x, and then over secant is 1 over cosine. So this is going to be x over cosine squared x equal to 0. Okay, so I know that cosine is undefined. Cosine is going to be equal to 0 at pi over 2, but since that's out of the domain, I don't have to worry about it. So then I can multiply both sides by cosine squared, and when I distribute it inside of here, that's going to get rid of this one and this one, and so then what I'm going to have is sine of x times cosine of x plus x is equal to 0. Okay, now this guy, to solve this guy, well, I'm going to bring this guy over, the x, so I'm going to have sine of x times cosine of x equals to negative x. Now, here we have sine of x times cosine of x equals to negative x. So this isn't very easy to see because we don't know what sine of x times cosine of x looks like. But if we remember that 2 sine x cosine of x is an identity is equal to sine of 2x. So if you multiply both sides by 2, then what you have is this guy is equal to sine of 2x is equal to negative 2x. And so then you're wondering, okay, well, where do these guys equal each other? Well, this is pretty easy to see. If you draw a little picture, you can see that there's only one spot where they're equal. Sine of 2x looks something like this. It's an ugly picture, I know. But then negative 2x, well, that's just a line that looks like this. So the only spot where they're equal is actually at 0. So this guy has one solution, and that's x equals to 0. Okay, so before we do anything, let's bring this guy, let's make that guy positive exponent. So I'm going to bring it down to the denominator. So this is going to be cosine of x plus 2 in the denominator. Squared, sorry. Okay, now we know that the denominator is never equal to 0 because cosine plus 2 can never equal to 0. So that means that I can multiply both sides by that denominator and get rid of it. Okay. So then the only thing we're left with is sine of x equals to 0, and the spots where sine is equal to 0 is at 0, at pi, 2 pi, and so on and so forth. And also, oh, sorry about that. The positive and negative. So that's it. Dot dot. Okay, so first thing we look for is where is the denominator equal to 0 to see if it's undefined. But this guy can't equal to 0 because x squared plus 1 can't equal to 0. So what that means is we can multiply both sides by that denominator. 2 square root of x squared plus 1. And that's going to get rid of this denominator. And we're going to multiply this guy by 2 square root of x squared plus 1. So from that, we're going to get 2 x squared plus 1, because the square roots go away, and then minus 2x squared equals to 0, because we multiply this guy. Okay, so then we get, when I distribute this guy, I get 2x squared plus 2, 2x squared plus 2 minus 2x squared equals to 0. So these guys cancel, so then I'm just left with 2 equals to 0, which basically means that there are no zeros.